To get 3 questions done.
That's a lot.
It sounds like a very small goal. It is, I'm not entirely sure we're going to do it. 3 questions. Our goal is to try to get 3 questions done.
The class ends in 40 minutes, let's go.
I know. If it makes you feel any better, at the end of the year, we'll do 1 question an hour. Yeah. Okay, I want to go to number 5, which looks relatively innocent and is actually kind of horrible to solve. I think we came up with this later in the day. You know, I was saying that I didn't like the groups because it's kind of hard to call on people or whatever. We came up with calling on a group, and your group is responsible for answering rather than an individual. So we basically have 1 through 12. Does that seem okay? Others thought that that sounded less stressful. Because you're kind of as a group rather than individual. Okay. Let's see. We need somebody that's going to be in charge of starting every single day. Oh, you're moving to a group so that you have a... That's fair. Okay. Okay. Who should we start every day with? You're volunteering?
Yep.
All right, Sebastian. I was hoping you could go up to number 5 and do step 1.
As a group?
Oh, true. That's true.
You all hold the pen.
Yeah, you're right. That doesn't really like mesh together, does it? To have an individual starting. Sure. Okay, we are taking the derivative, obviously. I mean, that's all it says. When we're done, we want to solve for dy dx. And while they're up there doing that, it wouldn't be a bad idea for you to try the first step of the derivative. Dan, put away the computer. You're not going to be able to fit anything up there.
Yeah. Can't you make it like skinnier?
Yeah, you tap on the line for the thinness.
Oh yeah. The line for thinness.
Whatever it's called.
No, it's not that.
It's the one that looks like lines.
Yeah,
Towards the right. Yep. Tap on the marker icon again. It's switched to drag. Yeah. The smartboard hates you.
Okay, no. Okay, you're good. Okay.
No, you actually did a pretty good job fitting a lot of stuff up there.
Okay.
Oh,
Do you
okay.
want it? No, you got it. Oh, okay. Oh, wow. Oh, wait. That's the first step.
All right, so is that what we're going with as a group?
Yeah. Yeah. Okay.
Because that kind of looked like just Walter.
No, we agreed.
Oh, okay. Neil?
Yeah, I agree.
Oh, okay.
We had a consensus.
That was consensus.
Yep.
Anybody disagree? Or feel like they got something slightly different?
I agree.
Shouldn't agree.
I should not.
Don't agree with it.
Doesn't the y on the left side, don't you need to have like y times dy over dx?
No, that part is kind of correct. The product rule was done correctly, I should say.
Does the product rule need to be in parentheses?
Yes, yes. You're the one that wrote it.
Oh, I didn't know.
Oh, yeah, the product rule did need to be in parentheses because the whole product rule is being multiplied, not just the one height. Thanks. Okay, one other minor issue.
Is there not supposed to be a Y on that side?
Correct, good. So I think you were more preoccupied with the marker at that stage, and I think you overlooked that part. So this should just be 3 dy dx. Yeah. Yep, everything else was great. Okay, now we got that, so, derivative of cosine is negative sine, keep the same angle. Multiply by the derivative of the angle, which is product rule. Dan, you're having a rough start today. And then on the right-hand side, take the derivative of x, which is just the 1, derivative of 3y, which is just 3, and then the derivative of y. Okay, now, from here, why does this one end up being kind of horrible to solve for dy dx? Cause, wait, what, say it again?
There's no zero.
Oh, I got you. You have a lot of difficulty putting the terms next to each other. I think that's what you kind of meant by the no zero. The 1 dy dx is within a parentheses. The 1 is out. And for us to be able to solve for dy dx, we have to be able to take those two individual terms and put them by each other. But we can't do anything with this term until we multiply it out. So we have to take negative sine xy and multiply it times both of those. So we have negative x dy dx sine xy. I'm going to put that in parentheses so it's not so. And then we have plus, well, times negative, so minus y sine xy equals 1 plus 3. I'm not going to plan on doing that problem, so I guess I can just go over there. dy dx. So we technically only have 4 terms. It just looks like a, oh, did I make a mistake?
No.
Oh,
I don't
negative,
think so.
okay, yeah.
I just have a question on the, first step. So when, on the right side of the problem where it's 1 plus 3 times dy over dx, why do you only leave the dy over dx with the 3 and not with the 1?
So taking the derivative of the x, is going to be a separate problem than taking the derivative of 3y. So the derivative of x, derivative of a plane variable is 1. And then I think maybe what you're kind of asking about, Walter somewhat skipped the in-between step that we did yesterday. It should say 1 dx dx, which turns into 1.
Oh, yeah, okay,
So they were done similar.
okay.
If you guys have dx on your paper, your work, that's totally, absolutely feel free to do that.
Sorry, can you explain what you took out, or did you distribute in for the second step?
Second step, I guess I've never heard it described that way, but I guess that's correct. Distributed in. I took the thing on the outside times both of the terms on the inside. So the inside, the plus sign right there meant that there's 2 terms.
Yeah,
And
I
then
see
I
it now.
took, okay. So I'm going to take each of the dy dx terms, group them together. I think I'll probably put them on the right-hand side because then they'll both be positive. So I will add this term to the right. And then I'm going to subtract 1 to bring it over to the left because I want to make every term that doesn't have dy dx on the left. So I'm going to have negative 1 minus y sine xy equals 3 dy dx. Are you okay if I factor the dy dx right away, or should I write that in? Write it in, all right. 3 dy dx plus x dy dx sine xy. The order you write the terms doesn't matter either. Like I wrote x dy dx sine xy, but those 3 terms can be written whatever order. I usually try to write the trig last so that you don't confuse the angle with other things. Okay, so factor dy dx out. I don't have to factor out a negative symbol, but I can pretty much guarantee they will on multiple choice, so I'll just get you guys used to that. I don't know why they do, they don't like the leading term to be negative. And then I'm gonna divide by that whole big parentheses. So this ends up being a lot like yesterday's, where the first step is the only step with the kelp. Everything after that is just a lot of algebra. Okay, final answer. It looks relatively innocent from the start, because it wasn't a very big problem, but the trig with the product rule, it's a frequent question on the AP test and or on our chapter tests. Can pretty much guarantee you'll have one like that on the chapter test.
What's the like notation when you're solving for these? Like you know how we did like f prime of x equals like for every step when we were solving derivatives?
Oh, got you. So at the beginning, I don't know if you kind of remember how I wrote it yesterday. Yesterday what I did was like the first step is I usually rewrote to the original problem. And then the notation that says you're doing the derivative would be this. So we're not gonna have like an f prime equals type labeling. The fact that you're just writing the equal sign on each line and doing the various work is kind of the labeling.
Okay, so you just have to start with that, and then when you go down, you can just do the work.
Correct.
Okay.
It's not terribly different on function notation, but we generally never have to solve.
For your test, is it okay if we just leave the negative sign?
100%. Yep.
Okay.
Yeah, there's like 5 different ways the final answer can be written. I don't know how lost you are. But... I mean, I kind of figured. I mean, like the algebra, I know you go to the algebra part. How are we feeling on that one? Like, is there steps you want some help with or explanation or anything?
It's been like 2 to 3 again.
Is that from here to here?
No, the other side.
That one to that one? Okay, so the dy dx that I'm trying to solve for is within that parentheses, and I can't just like take it out of the parentheses. So the only way to get rid of the parentheses is to take whatever's in front of it and distribute it to both terms. And so then I just took this times each term, and then there was no parentheses on this.
Yeah, I meant,
Oh,
sorry, it's okay. I meant the one that's like the 2 middle ones. Yeah, those two.
on the left-hand side, they were both negative, so I factored the negative out, but you don't have to do that. On the right-hand side, both of these terms had a dy dx, and so I factored that dy dx out,
Okay.
and then wrote everything that remained inside there. If you guys are feeling semi-okay about this, I was hoping you could try number 7 on your own. And then we'll have you guys call on a group, come up here and write some stuff down. Glacia, did you forget it was R&R today?
Yeah.
Do you not have a first hour?
No.
Okay. in general, what we're doing is we're doing derivatives on equations that aren't like pi equals. So like variables are all over the place. And the derivative is always gonna be the same, like when there's a power, you do power rule. It doesn't matter if it's an x, a y, z, a d, you know, you do power rule, you do the trig derivative, like the derivatives themselves are always the same. And then chain rule, sort of, like we don't know what the y stands for, or, you know, anything like that. So if we did the derivative on a y, we follow it up by multiplying by the derivative of y, like derivative of the inside kind of. And we write that as dy dx. If it's an x, like we traditionally use, that technically has it as well. But the derivative of x dx ends up being 1. Because it's the same info on top and bottom. If we take the derivative of a t, at the very end we'll write dt dx. Like whatever letter you take a derivative of, you kind of write it afterwards almost. Like sort of like the chain. Actually, what I probably should have had you do is just go watch the video during class today. That might have actually worked well. Because it probably isn't, like, these more complicated ones aren't going to make any sense. Until we took quite a long time doing these first one together talking about this. What time are you guys choosing so they can get started? 1 through 12. 7. 7. You guys are in charge of the start of the next problem.
What I got this for the I'm sure.
Yeah, well, I think, yeah. Wait, did you have 2y minus x? Because I'm confused about my negative sign.
I think we just really did it. We did this. 2y minus. Yeah.
That's correct. If we, because you did it.
What kind of group effort is this? Raymond, you ditched your group mate. Oliver.
Yeah, I must have just done it a different way, but I needed to see.
Ooh. Is that an X, I'm guessing?
Okay.
Okay.
Oh, what I did was I subtracted these two to that side, and then I factored out dy dx.
Oh, you didn't subtract the whole. But this is multiplied, you can't just subtract it. Why?
You know, I factored it out.
Oh, they,
Before subtract.
no, you just wanted that.
I didn't do 2 y.
Oh,
I did
yeah.
So 2x and y.
Okay.
That's what I
No,
did
it's,
too. And then what did you
y
do
minus y1 equals.
after that?
I just
Factored out the dy dx.
Yeah, and then I divided by whatever is expected.
No.
Oh, no, I didn't.
I got negative 4.
What I got was negative 2 plus y or negative x.
Because these, that's what I got first. But this says negative 2 times negative 1, which is 2.
And then that's just negative x
What did you do?
times 1.
So I guess you factor it out.
I got one bit.
Negative x plus 2y.
Based on.
That
Oh,
one.
this.
I got 0.
No, but like for this step, negative x plus 2y.
Does that say 4/5?
That's the slope, right?
No, that's, I'm understanding. I just have trouble reading your writing. Nope, it looks correct so far.
This is slope.
Yep. Okay, but, yep, so you're not done? Got it.
I'm not sure. I could also.
Your X looks exactly like an N to me. It throws me off.
Yeah.
Yeah, that's fine. It's not wrong. I just,
So what's the slope potential for this or?
4/5 or 0.8, they're the same thing.
That one's.
You can scroll down. You want me to scroll down for you?
No, yeah.
I suppose too late, you're already kneeling, okay.
Are you scoring?
I always do that test, like I'll do it right on the and then
X, which is -1.
No, no, I didn't say that.
Right.
I wrote 1 instead of for the x squared.
Had a way to help Oliver. You kind of just took over and ditched him there, though, Preba.
I remember calling you.
You could do it.
These go back.
Anybody else get the same answer? I mean, it looked correct to me, but, okay. So y minus 2 equals 4/5 x plus 1. Now, the most important part of all of this is basically right here, this first line. Like, that's where all the mistakes are. No, I shouldn't say it that way. That's where most of the points will be given for, is your derivative. The rest of this is all algebra work that you're supposed to be good at, but a lot of you, tend to make like minor mistakes there. So the first derivative, here it is. First derivative is going to be 2x, and then the derivative of x is 1, so you don't need to write that. And then the product rule of xy is going to be x times dy dx plus y times derivative of x. And correct. So the product rule, this is a very common mistake, is to forget to multiply out the minus sign to both of those. So I usually try to get in the habit of always writing the product rule in a parentheses, because frequently there's going to be things in front of the product rule. And then the derivative of y squared is 2y times the derivative of y. And derivative of 7 is 0. Now, here's the other, I'm not sure how I should phrase this. Because we were going to be plugging in a number, this line right here, the very first line is the derivative. Like, this isn't any better or different derivative than the very last line that says dy dx equals y minus 2x over 2y minus x. Like, those aren't any different. They just look different. So you can theoretically plug in -1 and 2 in this very first line and then solve for dy dx. Sometimes that's quite a bit easier because a lot of the numbers can combine together.
And then would you just factor out the dy dx?
You won't need to factor it because, well, kind of.
Take it.
You multiply out the number in front. Yeah. Either way, you should end up with 4/5. If you want to write it as 0.8, go for it. So y minus 2 equals 4/5 x plus 1. And then, Oliver, I'll let you choose here. What about the other table?
What number?
Yeah,
3.
3. Sophia, I think you're 3. It's kind of rough having you by yourself. Do you want to be part of 2 for today? Oh, okay. So 2, 3. I was hoping you could tell me the answer to the normal line without doing any work.
Is it y minus 2 equals -5/4 x plus 1?
Perfect. The normal line is just going to have the perpendicular slope. Everything else is the exact same. You just fix the slope information, which would be -5/4. And then that would be the normal line. That was good. Okay. What time did we get done? 06. We have raptor time. We have R&R today and raptor time tomorrow. R&R Thursday. Don't forget to sign up for an R&R. So raptor time isn't gonna, because we're not reviewing for a test tomorrow, it won't really throw us off. So
pictures too.
Let,
Like our freshman year, that's it.
why don't I do number 8 with you guys, so that we can get it done by 06? So we can get our third problem done.
Second.
Yeah.
Yeah?
The second.
Brooke. Fine, your table.
Okay,
What does d squared y dx squared mean?
the second derivative.
See, why, like, you got all freaked out that I called on you.
No, I thought it was gonna be like solid.
Oh, tell you to come up here and do it?
Yeah.
Oh, no, I would have called on the group. Okay, so second derivative isn't a big deal. However, because we don't have, you know, nice notation like function notation, we have to kind of work with that. So before we can find the second derivative, we have to find dy dx first. So we have to find the first derivative and solve for it. Now, it does actually technically say all of that right above this, but I know you guys usually ignore that, so I was just gonna put it on there. Okay, derivative of cosine of y is gonna be negative sine of y times the derivative of the angle, which in this case is the derivative of y, dy dx. On the right-hand side, we're gonna have the derivative of x, which is just 1. And if you want to write times the derivative of x, go for it. I just want to save space. So we have to solve for dy dx first. This is getting annoying. I also realized that I already broke my rule and I was trying to tell you I was going to do good notation. I should have started with that. So 1 divided by sine of y. It was negative over there. Am I thinking that wrong?
No.
Okay. Sometimes the easy ones are the ones my brain just absolutely overlooks. So I'm kind of torn. Part of me wants to leave it like this because sine is nice and easy. But I really don't want to use the quotient rule either. So instead of writing it as sine, I'll write it as cosecant.
Wait, why'd you switch it to cosecant?
Then I don't have to use quotient rule.
Rule is from symmetry.
Come on.
1 over sine.
It wouldn't be wrong if you left it as negative 1 over sine. It wouldn't be wrong, you could do quotient rule. I just don't like the quotient rule, it's a lot slower. It's a lot more work.
Could we write it as negative sine y to the negative 1 power?
Well, yeah, but that's cosecant. So, I mean, like, you can, it would still work. Okay, this is the first derivative, and this is the notation that means the first derivatives. So, from this step, I am going to take the derivative of this whole line. And this is actually where d squared y dx squared comes from. D over dx times dy over dx will be d squared y over dx squared. Basically, we did d dx twice on the y. Okay, derivative of cosecant. Oh boy. Okay, so derivative of secant is secant tan. Derivative of cosecant is cosecant cotan, but negative. So that will turn this positive. Why did you sit there then? Well, I told you guys to sit wherever you wanted. I'm right-handed, I don't really have a. If you want to know the truth, I had one professor that I'm still in awe of, whatever, 25 years later. He could stand at a chalkboard, we didn't have whiteboard. He would stand at the chalkboard with a piece of chalk, and he could stand here and look at you and talk to you and write, which by itself was crazy enough to me. He could do it with both hands. Like he would sit here on this side and just write for a while, and then he'd move over so you could see the rest, and then he would just start writing like backwards like this. And I'm like blown away. I don't even know how you would have like practiced that or like.
Then you should learn how to do
I
that.
got this. So I need positive. What do I need? What did I need to get? Positive cosecant cotan.
You
But
can't
you're
look,
looking though. You can't look.
Yeah, and you're a cosine.
There is so many things going on that I can't comprehend that. Like I already have a hard enough time talking and writing like normal. I definitely can't do that. I can't even try to figure out how to make my hand work backward. Okay, cosecant, cotan.
Would it be negative?
The negative symbol up here, the two negatives together make positive.
Oh, gotcha.
I was waiting for somebody to tell me it was wrong.
Because
Yeah,
we
done.
don't
DY dx. It's super easy to forget that. I mean, like, without question, you guys are going to find that that's the hardest part to remember by far. Okay, now here's the issue: is this isn't correct. This isn't going to be the answer on any answer key, and it's a technicality, and it's super annoying. If you are trying to find d squared y dx squared, you're trying to find the slope or something, right? And so, what would you be given to try to find a numeric slope? A point. But if I plug in x's and y's, I can't find the answer because of that. So, answer keys won't give this as an answer because you're not able to just plug in a number. So then the next step is I replace that. What do I replace that with?
Negative cosine.
Well, yeah, either one of those. I'll replace it with negative cosecant just because we already have that. So you're going to use the first derivative answer. Come on. You know, the old smart boards were so much better when they were done. So you're going to end up replacing that when you do second derivatives. It's not like it's hard. It's just, it's not something you would have probably naturally figured out or thought to do on your own.
When you like added that dy dx on the end of that whole thing, is it because you're first taking like the derivative of the outside thing, like the
Yeah, so the cosecant cotan was the
y?
derivative of the outside,
Okay.
and then the derivative of the inside was dy dx. Yep. So we have negative cosecant squared y cotangent y. It's not hard, it's just, it's not intuitive to think to do it on your own. I don't know what to tell you, I'm right-handed,
No,
this is
not
where I've
that.
stood all year long.
No, I'm just thinking about the problem.
Oh, okay,
That's
sure,
what I
sure.
was-
You were laughing about the problem?
Yeah.
I see. Well, it is kind of funny. Maybe I'll see if I can move the fridge or something.
To the fridge? Oh. Right.
I mean, I should probably move the fridge anyway, because every time the fridge clicks on and off, it shuts the whiteboard on and off somehow.
It turns on when you say fridge?
Definitely not. Whenever the compressor kicks on and off,
Oh.
they're not even plugged in on the same
Outlet?
outlet. It just doesn't. So I was debating moving that to my office. But it's been here for like 13 years now. Can't move now.
Yeah.
Okay, this is all I had actually. We made it through all three problems. We got 3 minutes to spare. So tomorrow, I will most definitely answer questions from homework. I'm not gonna give you a day to work. Shocker, I know, but I have another appointment Friday. So Friday will end up being a work day. So I'm gonna basically keep teaching straight through till Friday, and then you'll probably be backed up with work. So that shouldn't be a problem.
So 3, 4 tomorrow.
Yeah, we will definitely start 4 tomorrow.
Alright.
And I'm not expecting you to be done with the work from 3, but get what you can done so you're not falling behind.